Hello everybody, this is lesson number 2 of Unit 1. It's all about simplifying fractions. You will need to be able to simplify fractions without calculators, so we want to make sure that we can do that prime factorization that we learned about in lesson 1 and use that for simplifying fractions. Alright, so here we go. We want to remember that fractions are rational numbers. Anything that can be written as a fraction defines it as a rational number, which means it can be written as a numerator over a denominator. Let's take a look at something fairly simple. We want to take the fraction 6/8 and we want to reduce it into lowest terms. Now I'm going to go through this the long way, which would be taking the 6 and the 8 and doing that prime factorization for each. Remember, 6 is a composite number, and I can write that as the product of 2 multiplied by 3. And because 2 is prime and 3 is prime, I'm finished with that one. 8 is also a composite number and can be written as 2 multiplied by 4. 2 is prime, but 4 is not, so I can break that 4 down into 2 times another 2, which means that to write 6/8 as a product of its prime factorization, I would replace the 6 with the 2 multiplied by the 3, and the 8 I would replace with 2 times 2 times 2, all those prime numbers. Now, because we can break fractions up when they are written as factors and multiplication is the operation going on, this really becomes 2, I can write this as 2 over 2 times 3 over 2. And because this other 2 is in the denominator, that's like saying I have a 1 over here. And although we never really do this, when we're canceling out common factors, we are realizing that something like this, with the same numerator and denominator, is equivalent to the number 1. So I can replace that whole thing with 1, and what I get left is 3 times 1, or 3, over 2 times 2, which is 4. Now I'm going to back this up, even though we've got this reduced to simplest form here. I want to back up to looking at the prime factorization in this factor over here, 2 times 3 over 2 times 2 times 2. What we are more used to doing is canceling out common factors. So canceling out the 2 here with the 2 in the denominator, and understanding that that really does equal 1. We kind of write it like this, and then we realize that we are left with 3 over 2 times 2, or 4. So what I really want you to get out of this example is that when we are canceling common factors, we're really doing this other step in a shorter manner. We're really replacing common factors with a 1. Now, I don't expect that you're going to take a fraction like 6 over 8 and reduce it to lowest terms by using prime factorization, because what most of you would see is that there is a greatest common factor between the 6 and the 8, and come up with that being 2, and just divide the top and bottom by 2. And doing this method, we still get our lowest terms of 3 over 4. So whichever way works for you is fine. You just want to make sure you can get it to lowest terms. And sometimes when you have larger numbers, the way to do that is using this first method, where we go with prime factorization. All right, let's look at another example, 12 over 15. If I think about 12 and 15, I might be able to see that there is a common factor. Greatest common factor is 3, and I can divide top and bottom, or numerator and denominator, by 3, and I get 4 over 5. And if I look at 4 over 5, I want to make sure that there is no other common factor between a 4 and a 5. There is not, so then I am finished. If there was another common factor, I would need to divide the numerator and denominator by that same common factor yet again. Let's take a look at another example, 105 over 30. This is an improper fraction. My numerator is larger than my denominator, but I still want to reduce it and get it into lowest terms. Now here's a case where I don't, off the top of my head, know what the factors are of 105, and I would not be able to figure out what the greatest common factor is between 105 and the 30. So I'm going to go ahead and use that prime factorization method. I'm going to take my 105 and see if I can break that down. Now I know that any number that ends with 0 or 5 has to be divisible by 5. So I know 5 multiplied by something will give me 105. So if I do that division, I'm going to get 5 times 21. 5 is prime, but 21 is not. 21 can be broken down into 3 multiplied by 7, and both 3 and 7 are prime. So now I have 105, which can be written as 5 times 3 times 7. And it doesn't matter what order I write these in. Now I want to take a look at the 30, and I want to break that down into its prime factorization. 3 and 10 are two factors of 30. 3 is prime, but 10 is not. So I'm going to break 10 down into 2 times 5, and both of those are prime, so I'm finished, and I have 30 equivalent to 3 times 2 times 5. Now, if you notice, I have a couple of common factors in my numerator and denominator. The 3's would cancel out to be 1's, and also the 5's, which leaves me with 1 times 1 times 7, which is 7, over 1 times 2 times 1, which is 2. And that is reduced to lowest terms. All right, let's take a look at another example. This is on the next page. We have a word problem. And in this problem, Laura's having a party. She has 4 six-packs of soda in a cooler. 4 six-packs, I'm not sure if that is bottles or cans. I'm going to just use bottles for now when I talk about this. At the end of the party, Laura finds that she only has 4 bottles of soda that have been consumed. So she started out with 4 six-packs, or starting number of bottles, 4 times 6, or 24. I'm going to say it's bottles, although it could be cans also. Starts with 24 of these bottles, and at the end of the party, only 4 have been consumed. So at the end of the party, she's left with 24 minus the 4 that are consumed, 20 sodas left at the end of the party. We want to know what fraction of the sodas are left. So what we have left is 20 out of 24. Now in this problem, it tells us to write our answers in lowest terms. I want to give you a warning. You should always reduce your fractions to lowest terms, but don't erase your work, because if you make a mistake in reducing, there's partial credit available most of the time. So I want to make sure that my 20 over 24 is showing on my paper, showing my work, but I now want to go through and reduce this. And also, with your college work, anytime you are left with an answer that is a fraction, you should always reduce it regardless of what the directions tell you. Well, I shouldn't say regardless, but even if they tell you not, if they tell you find your fraction, always reduce. The only time you would not is if they specifically tell you not to. So a couple ways I could do this. Some of you might recognize that there is a greatest common factor with 20 and 24, and you might recognize that that is 4. So if I reduce it by dividing top and bottom by 4, I'm going to get 20 divided by 4 is 5. 24 divided by 4 is 6. And I want to just take a look at that and make sure there are no common factors between my numerator and denominator. There's nothing common between the 5 and the 6, so I'm finished. Now supposing I did not recognize that 4 was the greatest common factor, but I know that these numbers 20 and 24 are both even numbers, so they would be divisible by 2. If I did that, I would get 10 over 12. I really need to make sure I look at this fraction, 10 over 12, and check again, is there another common factor? And in this case there is. Both are again divisible by 2, so I need to reduce that again, and I can get 5 over 6. Same answer, it just took me a couple steps instead of one step from the previous example, but still get to the right answer. So for this problem, what fraction of the sodas are left? 5/6 of the sodas are left at the end of the party. And there's our answer. All right, that's it for lesson number 2. Tomorrow we will continue with lesson number 3. Have a great day, everybody.